Hey guys, so today we're going to go over a very brief lesson on intermediate value theorem. They touch upon it very briefly in section 202. So the intermediate value theorem will give you an idea of where the zeros are for the function. So I want you to keep in mind a zero is the same thing as when they tell you to solve for x. So if you're given a function and you're solving for the x values, that's the same thing as finding its zeros. Graphically, they're also the x-intercept. So anytime you are solving for x, you're solving for the zeros. Those are technically the values that are on the x-axis. So I'm just going to just graph a parabola, and the point that touches the x-axis would be known as the zero, which are graphically the x-intercepts. So how do we find them using the intermediate value theorem? So I just want to keep one thing in mind. This will give you an approximation of where the zero is. It's not going to tell you exactly what x equals to. So for this given question, which is under your lessons for 202, they gave you the endpoints, which they call A and B. So we're going to plug these x values in. So for f of -1, because the first x value is -1, I'm going to replace all the x's with -1, and then keep in mind PEMDAS after that, exponents before you multiply. And just on the side, I'll also make an xy table. So -1 to the third power is -1. I'm going to bring down everything else. -1 to the second power is 1. Please make sure you put it in parentheses if you plug it into your calculator. Otherwise, it'll come out as -1 rather than +1. And then after exponents, we multiply. We have 2 plus 3 minus 1. So we have 2 plus 3, which is 6, or sorry, 5. 5 minus 1 gives you 4. And then from here, we're going to solve the other y value, which would be f of b. So the second endpoint is at 0. And I'm going to replace all of the x's with 0. And then the nice thing about that is anything multiplied by 0 is just going to give me 0, no matter if I square or cube it. So this will just give me 0 minus 1, which is -1. Okay. So how does this tell us where a 0 or an x can be? I'm just going to give you a brief sketch of what's happening here. All right, so there is a point at 0, -1. So I'm going to plot a point there. And there is also a point at -1, 4. So somewhere between x is -1 and x is 0, I had to go from this point to this point. So somewhere between these two x values, I crossed the x-axis. Remember, any point that touches the x-axis is known as the x-intercept. That's where the zeros are. That's when you solve for x, where the x values are. So that's how we showed that there is a 0 between the interval -1 and 0. There's a sign change. Because if you look, anytime you go from the positive y-axis to the negative y-axis or vice versa, you have to cross this x-axis to get there. And any points on the x-axis are the x-intercepts, which are the zeros. Okay, so we're going to just use a different problem as well. Use intermediate value theorem to find where f of x, sorry, I'm missing that part, f of x equals x to the third power minus 4x squared plus 2x minus 7 is guaranteed to have a 0. So in this case, they don't give you the x values. You kind of have to use, your Algebra 1 skills and plug in the x values that you want and see if there's a sign change in the y values. When there is a sign change in the y values, that's where you're guaranteed to have a 0. So I'm just going to find some values to plug in. Using x is 2, I'm going to replace all the x's with 2 and test this out. Exponents come first, and then from there I can start multiplying. So what I have is 8 minus 16 plus 4 minus 7. Once we are doing adding and subtracting, you're just going to go from left to right. So 8 minus 16 would give me negative 8, plus 4 would give me negative 4, and then minus 7, which would be negative 11. And then from here, I'm going to plug in the next x value, which is 3. So technically this should say f of x, or f of 2, equals all of that, and then f of 3. So I'm going to replace all the x's with 3. So this will be 3 to the third power minus 4 times 3 squared plus 2 times 3 minus 7. So exponents first, this will give me 27 minus 4 times 3 squared, which is 9. And then after exponents, I can multiply. So I have 27 minus 36 plus 6 minus 7. And again, once it's adding and subtracting, you can just go from left to right. So we have 27 minus 36 plus 6 minus 7, and that'll give me negative 10. So there are no zeros yet because no sign change has happened between the y-axis. So I haven't actually moved from the negative y values yet. I'm still here. Once I move from negative to positive, I've crossed the x-axis, and then I can find a 0. And then from here, I'm going to replace all the x's with 4. So I have 4 to the third power, exponents first, which would give me 64, minus 4 times 4 squared, which would give me 16 after exponents. Then you can multiply, and then you have 64. You have 4 times 16, which would give you 64 as well, plus 8 minus 7. And then just go from left to right when it's adding and subtracting. 64 minus 64 is 0, plus 8, which would give you 8, and then minus 7, which would give you 1. So since it goes from negative to positive right here, that's using the intermediate value theorem to tell you that somewhere between where x is 3 and 4, there's going to be a 0, because I went from negative 10, where x is negative, or where y is negative 10, all the way to where y is 1. So somewhere I passed the 0, which is the x-intercept, which is the point on the x-axis. All right, guys, I hope this helps.